Welcome back. We're on chapter 7 now, our second part of the algebra part of college mathematics. Here are some of the things we're going to talk about today, and we'll get to those one piece at a time. First of all, the horizontal number line is the x-axis. I'm going to double check. Yeah, good. So here's the x-axis. Should be familiar with that, the one that goes all the way through horizontally. The vertical axis is the y-axis. Here's the x, and here's the y-axis up here, or along the vertical part. The origin is where those two meet in the center. Negative numbers to the left, positive numbers to the right. The axes divide the plane, also called the Cartesian coordinate system, into 4 quarters, appropriately called quadrants because there are 4 parts. Next, every point in that coordinate system is identified by an ordered pair of real numbers. The first coordinate is the x-coordinate, the second coordinate is the y-coordinate. So if you've got a point like -5, 3, you start at the origin. The -5 tells you where to go on the x-axis. The y-coordinate tells you where to go on the y-axis, where to go vertically. There's your point, -5, 3. -5, +3. For 3, -5, you go +3 and then -5, and that puts you down here. That's how we locate points. So can you plot these points? You might want to pause the graph. And if you need some graph paper, just make up your own, really. You can also get some free graph paper if you're interested. Check with me and I can tell you where you can find that. So here's how you would find those 6 points. -3, 5, 3 left, 5 up, and there's your point. Right there. Next, 2, 4, 2 right, down 4, there's your second point. Third one, 5 units right, 0 units up or down, there's point C, and so on. I hope you can get those pretty easily. Next, if we want to express a relationship between the two, we use an equation in 2 variables because we've got x variables and y variables. The solution is one where you have a pair of real numbers, you put them together with an equation, and it makes the equation true. Put the x-coordinate for x, the y-coordinate for y, and it says something true. If you graph all of the points that make it true, then you've got the graph of an equation in those 2 variables. So here's an example. We've got an equation, y equals 4 minus x squared. Pick the integers you want to start with, the ones that will be x. For example, you might choose -3 through +3. Put those x values in one column, the first column normally, and the equation right here is going to tell you how you get the second coordinate for each of those points. Just put the x value in where the x is in your equation and see what you get. And there you get, there's your -3 you had for x, and -5 is what the equation told you was the corresponding y value for that point. Just follow that, -2 for x, put in your equation, and for this one you get a 0 for y, and so on down the line. Plot those 7 points, and when appropriate, connect them with a smooth curve. If it's a straight line, of course, excuse me, you'll use a ruler or some kind of straight edge to create your straight line. In this case, this is what we had, -3, -5, -2, 0, and so on, those 7 points. Plotted, there we go, those are the 7 points. And smooth in what we can tell is the curve. It's not a straight line, so of course you have to use your artistic ability, whatever exists in you, and create that smooth line. Now we have something called functions. Functions are very special. It means for every x, pick any x you like, put it into your function, you'll only get one y value that's associated with it. Put one x in, you get one y out. If you get more than one y value out of your equation or your function, then it's not a function. This is the notation we use. Y and f of x mean exactly the same thing. This is the y value. The reason for this notation is that we've named the function f. You could call it anything you like. We'll call this one f. And the x here means that to get a y value, we're going to start with an x value. And this function depends on what we pick for our x's. We read it f of x, or the function at x. Okay, so tailgaters beware. You can read this. Pause it a second. We'll see a figure on the next slide that shows you the graph of the distances and the speed. Here along the horizontal axis, you'll see the speed. And for each of those speeds, it tells you what the stopping distance is. First in green for a dry pavement stopping, and blue for stopping on a wet pavement at that speed. If you put those two together, this is for dry, so you just take the green bars we've got here, 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 and here, graph those on our XY coordinate plane or Cartesian coordinate system. Notice that it's not a straight line, so you have to sort of use your artistic ability and sort of smooth that in the best you can. Using a line graph, you can estimate the car's required stopping distance at 60 miles per hour. So you can sneak back here if you wanted to. Where is 60? Well, 60 is here. So what's the stopping distance? Well, this go straight up and over, and that's going to tell you what the stopping distance is if you're going 60 miles per hour on dry pavement. And then round it to the nearest 10 feet. And it comes out to about 360 feet. Now it's hard to do it from a graph like this, but you just do the best you can. So you can read through this. So 360 is a good estimate for the stopping distance on dry pavement if you're traveling at 60 miles per hour. There's your graph again if you want to refer to that. Here's the function. This function enables you to pick any speed at all, and you can find the stopping distance as a result. One way you can do that with your graphing calculator is you can take, for example, the 60. Take that 60, store it in the x in your calculator, and then type in this function right here, the 0.0875x squared. It's going to start using this x in the calculator, minus 0.4, same x, plus 66.6, and you can get your estimate. Now with this function, you're going to get a more accurate one because you don't have to make a guess as to where that function is going on your picture. So there's your function. Put the 60 in where the x's were. And of course, I showed you how to do it a little bit easier with the calculator. But it's not necessary to use the calculator. You can do it manually. And a little bit of simplification. And we get about 358. Remember, from the graph, or 357.6 to be more precise, on the graph we got about 360. Was a good that was a good estimate for using a graph like that. Next, what if we want to use some different functions? Here's another function. Graph that one. Again, pick some x's. Here are some representative x's. As long as they work in your function, they're numbers you can put in for 2x. So pick x's of -2, -1, 0, 1, and 2, and see what you get when you put them in this function. There are your y coordinates for those x values, and you're going to graph those. And then you're going to do the same thing with this second function. This was for the function f, this for the function g. Take those numbers -2, -1, 0, 1, and 2, put those in this function, and see what you get for the y values. And with those ordered pairs, graph those on the coordinate system. And when you do, compare the graphs that you get for those two functions. Now, if you're using your graphing calculator, which you really should, this is what you should see on your calculator. Some of you will actually see different colored ones, or you can choose a different color for different ones. It's all up to you, but you can see how those two match up against each other. Here's the 2x function, and here's the 2x plus 4 function. You can see what the difference is. The second one, the one right here, is like the first one, except it's shoved up 4 units. Here's the 2x, here's the 2x plus 4. If you took this blue line and shifted it up 4, you'd have the red line. Next, if a vertical line intersects the graph in more than one point, it does not happen to be a function. So here are some pictures that you can play with in your head. Can you draw a vertical line that hits it more than 2 places? Well, that's not a very good vertical line, but you can use your imagination. This vertical line hits that graph in 2 different places with the same vertical line. So it's automatically, just by using this vertical line, this graph is disqualified from being a function, because every x value on here has to have a unique one and only one y value that's matched up with it. If we take this x, it's matched with a y up here and with the y down here, so it's not a function. On the second one, part B, you can draw a vertical line wherever you want. It's only going to cross that line once, so this one checks out as a function. Next one. Well, this is curved. It's not like the last one, But again, draw any vertical line or pick any x, and there's only one y that goes along with that x. So this is also a function. That checks out. Last of all, notice C and D, quite similar. They curve in similar ways, but in different directions. But this one, here's a vertical line, one of many possible. It crosses at 2 points. This graph has failed the function test, the vertical line test, to be a function. It's not a function. So this one is not, B and C are, and this one isn't as well. And here's a summary of all those. And they've drawn some vertical lines for you, just as I did. You could take a second look at those. Here's another one about body temperatures. And those body temperatures, imagine someone in your family isn't feeling too well. So you take body temperatures from 8 a.m. to 3 p.m. So in other words, for 7 hours. How is that person's temperature going? Well, it wasn't too good at first, 101 degrees. A little bit later, it was 99 point something. Another hour later, it was down to just under 99, and then dropped down to 98 point something. Looks like they were normal, but then it spiked again at 4 p.m. and 5 p.m. and stayed that way till 7. Oh, missed something here. What was the temperature at 8 a.m.? Just go over to 8 a.m. This is hours after 8 a.m. So this is 8 a.m. right here. What's the temperature? Just go up here and see how high it is. It's 101. In what period of time is the temperature decreasing? Well, it's going down from 0 to 3 hours after 8 a.m. In other words, 3 to 11, the temperature was getting better. Estimate your minimum temperature during that time period. Well, the minimum is where the y value is the smallest, which would be right there, about 98.6. How many hours after 8 a.m. does that occur? Well, 3 hours. 3 hours after 8 a.m. During what period of time is the temperature increasing? When is it going up? Well, here's the low point. It's going up until it hits 5 hours after 8 a.m. And there's your most increasing. From here to here, the temperature is going up. Part of the graph is a horizontal line segment. What does that mean about your temperature? Here's a horizontal line segment. What does that mean for your temperature from 5 hours to 7 hours after 8 a.m.? Well, it means that it's staying stable. Why does the graph define y as a function of x? Y equals f of x. Because you can draw any vertical line, say this one for example, and it's only going to cross that graph, even though it's sort of a strange graph, it's only going to cross the graph one place. Now what does that mean? We're talking about temperatures, right? Your temperature. That means that at any point after 8 a.m., you have one temperature. You don't have two temperatures at the same time. Well, that makes sense, right? Your temperature is a function of what time it is during any particular day. You can only have one temperature when you take the thermometer out. So here's some summaries of what we've talked about. You can pause and read through these if you like. There's your minimum temperature. All those things we were talking about. All right in front of you. Well, folks, that's it for section 7.1. I hope you picked up a little bit. If nothing else, maybe a little bit of a review of what you already knew. And we'll see you again in 7.2, not too far from now. You take care of yourself and keep your temperature at 98.6 or whatever is normal for you. Until then, we'll see you.